Okay, so before you correct this, make sure that you've got your answers to the net ionic equations worksheet. You've got your periodic table out, and then you have a different colored pen or pencil as well, because we're going to go through and I'll work some of them pretty quickly, but I'm going to explain the first few in greater detail as well, and I'm going to have you correct your answers as you go along, and then we'll end up with a total points score as well. So here we go with number 1. Silver nitrate, that one splits up to be Ag plus and NO3 minus, because all nitrates are soluble, as you can read in the solubility rules right here. All nitrates are soluble. Don't forget the little plus one and the minus one here. Potassium chloride is also soluble, because all chlorides are soluble, or potassium's in a group 1 metal cation as well, so that's also soluble. Don't forget the little plus and the little minus right here. Over here on the right side, AgCl is a solid. Chlorides are all soluble except for silver, mercury, and lead, as you can read right here. Silver, mercury, and lead, and so that one's got to stay together as a solid. And then potassium nitrate, that splits up once again because all nitrates are soluble and so are all potassiums. So there's the complete ionic equation. Take your different colored pen or pencil and highlight or circle this area and give yourself +1 for that. Then when you write the net ionic, you'll notice that the potassium and the nitrates cancel, so you end up with Ag plus Cl minus goes to AgCl. That's worth the second point in number 1. So circle, square, star, box that, and put +1. Make sure that you recognize or circle these little pluses and minuses right here, so you make sure that you have those in there, because without the pluses and minuses right here, we don't know that they're ions, that they're strong electrolytes in solution. Okay, the second one now. Making sure that this is balanced, I believe we need a 2 right here to balance the equation. And then, yeah, that makes the nitrates and the sodiums balanced. Now, magnesium nitrate, that one is soluble, so Mg, and then 2NO3 minus. That's the first point in this problem, is that there's a 2 right here in front of the nitrate, so give yourself +1 for that. And then we have a 2Na plus and a CO3 2 minus, and that is aqueous or dissolved as well because it's got a sodium in it. Sodiums are always soluble. Magnesium carbonate is going to be a solid. It's not only indicated solid right here, but if you look in the solubility rules, you'll remember that all carbonates are insoluble except for the group 1 elements, and magnesium's in group 2. And then this one splits up into 2Na plus and 2NO3 minus over here, and that'll be our complete ionic equation. Now these guys cancel right here, the sodiums and the nitrates, so then your net ionic ends up being Mg plus 2 plus CO3 2 minus makes MgCO3, and that's the second point in this one, so we're up to 4 points total so far. Box that, put +1 next to it. If it's not correct, fix it on yours, and then put +1 next to it. Remember, you're only graded on this by how well you grade your homework. So make sure that you've got the pluses right here, and make sure you've got those things highlighted or circled or squared or starred or boxed, and make sure that you indicate those pieces, because that's what I'll look for. The next one is from words to formulas. So strontium bromide is SrBr2, and then potassium sulfate is K2SO4. Don't forget that potassium's +1 and sulfate's -2. And then on the right hand side we have strontium sulfate, +2 and -2, and then we end up with potassium bromide, which is KBr. So then we end up with needing a 2 right here to balance the potassiums and the bromines. Now we have to balance, some people just call this the molecular equation, and now we need to go through and decide whether they need to split up or not. And it turns out that strontium bromide does break up into Sr plus 2 and 2Br minuses, 2K plus and SO4 2 minus. Strontium sulfate, whoops, I'm sorry, this should be an SO4 right here, because it does say sulfate right there. Strontium sulfate, when you look at sulfates, they're all soluble except for barium, lead, mercury, calcium, silver, and strontium. So strontium sulfate, even though it has a little star next to it, is very much close to insoluble, so we leave that together, SrSO4, and that'll be a solid. And then we get 2K plus and 2Br minus over here. So your point for this one is to have the left side of the equation look just like this, with +2, -1, +1, and then -2, and the 2's right here in front of bromine and potassium. So put +1 on your paper if you have that part right. The items that cancel then will be the potassiums and the bromines, and then you're left with Sr +2 and SO4 2-, and this ends up being Sr SO4. That's worth the second point, is just having the net ionic equation correct, just like it's written right here. So we're up to 6 possible points so far for numbers 1, 2, and 3. Going on to the next problem now. Pause the video now if you need to correct any others of those. We're at number 4, where we need to go from words to formulas. So now it's manganese. Make sure it's manganese chloride. So MnCl2. It says aqueous right there. We know that's going to dissolve because it's a chloride. All chlorides are soluble. And then ammonium carbonate is NH4 2CO3. Make sure you got that formula written correct. And then manganese carbonate over here is MnCO3, and notice it's manganese 2, so that's +2, and carbonate's -2, so that ends up being MnCO3. And then we end up with ammonium chloride, so NH4Cl right here. To balance this equation, we'll need a 2 in front of the NH4Cl. That takes care of this 2 and this 2 right here. All right, to write the net ionic then, Mn +2 +2Cl-. This is aqueous. It not only tells us it's aqueous here, but we also know that all chlorides are soluble except for silver, mercury, and lead. Manganese is not that, of course, so it will split up. All ammoniums are soluble, so put 2 NH4+ and then CO3 2-. And this is what earns you the first point in this problem right here, is having the 2 in front of the NH4+. So notice how this 2 actually comes out front to indicate that there's 2 ammonium ions. And then there's MnCO3, which is insoluble, because all carbonates are insoluble except for group 1s and ammoniums. And then we have 2 NH4+ and 2 Cl-. Notice how this 2 distributes into both of these species. And if you did that, you're in the second point for this problem, so you get +1 right here. The net ionic ends up being Mn +2 CO3 2-, and then that goes to MnCO3. That's not worth a point this time. That gives you 2 more points, so we're up to 8 total. Then number 5, we have the chromium 3 nitrate. So chromium now is going to be +3, and then nitrate is NO3, so you get a 3 right here. And then iron sulfate, that's Fe, and it's iron 2 sulfate, notice, so it's FeSO4. And then on the right-hand side, it's chromium, and then sulfate, which is SO4. Chromium here is +3 again, so you're going to need a 3 down here and a 2 down here, because sulfate's -2. And then you get iron nitrate, and it's iron 2 nitrate, so FeNO3 because nitrate's -1 and iron is +2. So there is your skeleton equation. Now we have to balance it, and I believe we end up needing a 2 right here. I think we need a 3 right here for this one to make sure we have 6 nitrates here and 6 nitrates right here. This means we're going to have a 3 in front of this iron right here. And we see we have 3 irons here, 3 sulfates here, 3 sulfates here, 2 chromiums here, 2 chromiums here, 3 nitrates, 6 nitrates and 6 nitrates here. I think we have it balanced. All right, then we got to go through and split it up. And we got some clues here, aqueous, 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 but let's make sure that that works out right. So what that means is that all things are going to end up splitting up because all of them are going to dissolve. So before we go on to this, I apologize, I missed this part. Give yourself +1 for having the correct skeleton equation like this. That's balanced. Balanced skeleton equation is worth 1. Now everything splits up because it's all soluble. So you end up with Cr +2 plus, let's see, 2 times 3 are 6 NO3 minuses. Plus 3 Fe plus 2 plus 3 SO4 minus 2. Notice how the 3 distributes into each one of those species. The 2 goes here and it goes to the nitrate. That's why there's a 6 right here. And then on the right hand side, chromium sulfate was the one I was wondering about. But if you look at the sulfate rules, remember it's barium, lead, mercury, calcium, silver, and strontium, fabs. If you remember that from the video, those are the ones that cannot be soluble. And chromium's not on the list, so that means that chromium is going to be soluble. So you end up with 2 Cr plus 3, and then 3 SO4 2 minuses. And then you got to split this one up too, because all nitrates are soluble. So you get 3 Fe plus 2s and 6, 3 times 2, or 6 NO3 minuses. All right, the second point is to make sure that you have the 6 in front of the NO3 minuses on both sides. And then you see that everything cancels out, so this one really has no reaction that takes place because there's nothing that ends up making a precipitate. So it's not a precipitation reaction per se, because no precipitate forms. All right, we're up to 10 possible points. We'll come back and we'll grade this one in the next video. Oh, give yourself 10 out of 10 before you're done right here, and make sure that you've got that marked down so far.